the last number of days talking about friction. We said friction, if it was static, was mu, the maximum force of static friction was mu times the normal force. Kinetic friction was mu times the normal force. Static friction ended up being whatever force I applied unless I exceeded that maximum value, whereas kinetic friction was a constant value no matter how hard I pushed. We saw a couple of times that force of friction, because it was the only force, I had to set that equal to the net force, the total force, the unbalanced force. What do we do, though, if that's not the only force acting? What do we do if there's several forces acting on an object, if there's multiple forces acting on an object? In other words, what do we do if we have what we call multi-force problems? Well, the first thing that I want you to do is to draw what we call a free body diagram. A free body diagram is a diagram that shows all of the forces acting on an object. Shows all of the forces. Doesn't show anything else. Or doesn't need to show anything else, at least. Just the forces acting on an object. And if two forces happen to be opposite direction and equal magnitude on the same object, cancel them out. So in other words, if I push on Jacob with a force of 80 to the right, Christine pushes on Jacob with a force of 80 to the left, and Rachel pushes on Jacob with a force of 60 to the right, my force and Christine's force will cancel out. 80 to the right and 80 to the left will cancel, and then we're left with only the force that Rachel applied, which was whatever I said it was, 40 or 50 newtons, whatever it was, to the right. Right? These would cancel because they're equal and opposite acting on the same object. So draw a free body diagram, show all of the forces that act on the object, and if there happens to be two forces that cancel out because they're equal and opposite, then cancel them out. Get rid of them. Just scratch them out, or even erase them if you want to. Once you've done that, then I want you to take a look at what forces are left over. And if they're in one dimension, what do I mean by one dimension? Well, all the forces are either like this or they're like this, but you don't have both. So they're either all right-left or they're all up-down, but not a combination of both. If they're all in one dimension, then you want to do this. Say F net is equal to, I said F1 plus F2 plus whatever. What I really mean by that is the sum of the forces, all of the forces added together. F1 could be a force of friction. F2 could be an applied force, whatever. Okay, whatever they're called, you got to add up all of the forces that remain. So draw your free body diagram. Cancel out the forces that are equal and opposite. And then add up all the remaining forces and set that equal to the net force. Yeah, question? I'm sorry? Not yet. When we're doing a one-dimensional problem like this, no, you wouldn't have to draw a vector diagram. Eventually, when we're going to draw a two-dimensional force problem, then yeah, you would have to do a vector diagram, but that's coming later on. Yeah, same deal. We won't do three-dimensional, actually, but you do it almost the same way, just be more work. All right. So there's what you do. Draw a free body diagram, and then set F net equal to the sum of whatever forces are left over. Now, if necessary, you don't always have to do this next step. Most times you do, but not always. If necessary, you will replace F net with m times a. That's Newton's second law, right? F net is equal to m times a. Some questions just ask you for F net. Well, then don't do step number 2. Some questions ask you for the acceleration. Well, then do step number 2. Do whatever you got to do to get what you're looking for. All right, let's see how to really do this with example number 3.2 on page 132. This is chapter 3, right? When it says example 3.2, chapter 3, if you're downloading the chapter of the textbook. It says 2 people, A and B, are dragging a canoe out of a lake onto a beach using light ropes. Each person applies a force of 60 newtons, but there's a force of friction exerted on the beach, by the beach on the canoe of 85 newtons backwards. Starting with the free body diagram, calculate the net force on the canoe. So what's step number 1? Well, they tell me step number 1 here. Draw a free body diagram, right? What forces do we have acting on this canoe? Well, person A I'm going to call that the force of person A on the canoe. That's 60 newtons to the right, forward. And we also have person B pulling it with, we'll call that FB, 60 newtons forward. Agree? Is that good? Now we have a force of the beach, force of friction of the beach acting on the boat of 85 newtons backward. Friction is going to oppose the motion, right? So if we're pulling to the right, then friction is going to act to the left. So I'm going to draw that this way. Try to draw that a little bit longer than the 60 newtons. How come? It's 85 newtons. Okay, the applied force is 60 and friction is 85 newtons, so it should be drawn a little bit longer. There's my free body diagram. This shows the forces acting on this canoe. Now, when I want to find the net force on this, I'm going to go to, remember back here, step number 1 was, first thing is draw a free body diagram. And then next I have to set F net equal to the sum of all those forces. So let's say I got the free body diagram drawn. Now we say F net is equal to the sum of the forces. And write this step down. Don't skip this step. FF plus FA plus FB. 3 forces acting on this canoe. Include them all. Now, by the way, if I had 60 and 85 over here, and then 60 over here, 2 of the 60s would cancel, right? But since they're both in the same direction here, they don't cancel, and they don't cancel with the 85. So I've got to include everything here. Yep.
Why are your subscripts F and B?
I just call it FA and B because I call it the force of person A and the force of person B. Okay, I could have called it F1 and F2 or F whatever you want. Yeah, whatever. Call them whatever you want. If this is a quiz or a test and you call them F1 and F2, that would be fine, right? It doesn't matter what you call them, as long as you include 3 forces here and have the direction and magnitude right. Yeah, William?
This was a quick test?
Yep.
To write out all the
Yes. Yes. Yeah. Yeah, this is a quiz or a test. You want to show everything that we've shown right here. All right, what's next? Now, we said if necessary, say M times A. That's not necessary here. Since we're looking for the net force, let's just leave it as F net is equal to FF plus FA plus FB. Now let's do that here. FF is 85 newtons, right? FA is 60 newtons. And FB is 60 newtons. Agree? Agree? Josh? Absolutely. That's the main reason why we drew that free body diagram, was to remind us that FA is a negative value. Or not FA, but FF is a negative value. It's to the left. We make sure we include it as a negative value. So we add these up now. Negative 85 plus 60 is going to give me positive 35 newtons. The net force here, the total force acting on this canoe is 35 newtons. And since I got a positive value, Maddie, that it would be 35 newtons to the forwards, 35 newtons forwards. Okay, that makes sense? That's not crazy hard, is it? They get harder, obviously. Okay, but if you're with me on this, then that's a good start, at least. All right, I'm going to ask you to do a couple of questions on page 132 here. At your desk, see what you can do with that over the next couple minutes, okay? Take a look up here. We're going to take a look at number 2. It says, in a tractor pull, 4 tractors are connected by strong chains to a heavy load. The load is initially at rest. Tractors A and B pull the force with forces of 5,000 newtons east and 4,000 newtons east, respectively. That respectively just means like in that order. Tractors C and D pull with 4,500 west and 3,500 west. The magnitude of the force of friction exerted by the ground on the load is 1,000 newtons. What's the net force? So let's do question A, drawing a free body diagram. Here's the load. Okay, we have a force, we're going to call it FA, that is 5,000 newtons. FB is 4,000 newtons. And I'm going to make those to the east, which I'm drawing to the right there. Okay, why have I drawn that 5,000 newton vector a little bit longer than the 4,000 newtons? It's bigger. Right? It should be about 25% bigger. I don't expect you to take over a ruler and make sure the exact proportions are correct, but you should have the 5,000 drawn a little bit longer than the 4,000. Now, C and D pull to the west. C has 4,500, so it's somewhere around there. Should be a little bit shorter than A. Sorry, a little bit longer. Yeah, a little bit shorter than A. 4,500 newtons to the west, and then we have 3,500 newtons to the west for D. Okay, now it says there's a force of friction of 1,000 newtons. It doesn't say which way that acts. Anybody want to take a stab at which way that acts? What do you say to the left or to the west? Look at this force to the right here. 5,000, 4,000 is how much to the right? 9,000. How much to the left? 8,000. Okay, if you have 9,000 to the right and 8,000 to the left, then which way does it want to move? To the right. Okay, which way is friction going to act? To the left. If it wants to move to the right, friction is going to act to the left. So let's label that FF is 1,000 newtons to the left because you have it has to oppose the motion, and it's going to move in the direction of the 9,000. Okay, let's find the net force. Net force is all of those forces added together. It's a lot of them here. FC plus FD plus FF plus FA plus FB. Does it matter that I didn't go in order F, A, B, C, D, F? No, of course not, right? FC is negative 4,500. FA is negative 3,500. FF is negative 1,000. Notice I'm adding all these forces together but making them negative. FA is 5,000. FB is 4,000. Holy cow, there's 5 of these things. When we add all these up, what do we end up getting? 0 newtons, right? 0 newtons. Does it move? Is it initially going to start moving? No. An object at rest will stay at rest if the force is all balanced. If this was already moving, what would happen to it? It would keep moving at a constant velocity because an object in motion stays in motion at a constant velocity as long as the force remains balanced. Okay, how many people got that? Good, good. Let's take a look at another example then on page 150 here. 3.6. This one says 2 athletes on a team A and B are practicing to compete in a canoe race. Athlete A has a mass of 70, B is 75, and the canoe has a mass of 20 kilograms. So let's just pretend it's one thing. Canoe, person A, person B has a total mass of 165 kilograms. Right? 70 and 75 is 145, 20 is 165. So it doesn't matter. Like, physics doesn't understand that there's 2 people on this canoe. As far as physics is concerned, the canoe has a mass of 165 kilograms, right? Like, if one person was 10 kilograms less, but the canoe was 10 kilograms more, would it make any difference? Of course not. All right. Athlete A can exert a force of 400 newtons forward. We're going to say FA is 400 newtons forward. B is 420 forward. Notice I draw that a little bit longer there. There's water resistance of 380. By the way, I kind of ran out of space on the left-hand side here. Is it okay if I draw this? The force of the water, I'll call it FW. Is it okay if I draw it down below? That's one of the things about your free body diagram. It doesn't make any difference where you draw the force, as long as you draw it in the right direction and the right magnitude. Does that make sense? Like, I could have drawn FA over here if I wanted to. I just chose to draw it where I did. Okay, we want to find the acceleration. Okay, so remember, the first thing you do is draw that free body diagram. We've done that. Next thing you do is to say F net is equal to the sum of the forces. In this case, we're going to say that's FW plus FA plus FB. Is this right? I'm going to show you something that doesn't really matter to this question, but like most of you probably aren't thinking this right now. Some of you might be thinking, I think there's this, but I think he's missing something. There's actually a force of gravity acting down, right? Why did I not include that? Why did I not include that? What else is there? What other one am I missing? Buoyancy, or we'll call it the normal force, up. And what do we know about gravity and the normal force? Remember what we said a few minutes ago? If two forces cancel, then just take them out. So gravity and normal force cancel each other out there. So all we care about is this force of water, the force applied by A and the force applied by B. Okay, now we want to find the acceleration. So let's go to that next step that we haven't done yet and set F net equal to m times A as well. MA is equal to FW plus FA plus FB. FW is, well, M is 165. We have the total mass there. FW is 380 plus 400 plus 420. Is that right? Josh, is that right? I'm going to ask you because I know you know the answer to this. Good. 380 is negative. 380 is negative. So let's add those up on the right-hand side to get me the net force. 380 plus 400 is 20, plus 440 is, sorry, plus 420 is 440. The net force is 440. Whoops. The net force is 440. How am I going to get rid of the 165? Divide it. Let's say, can I borrow this for 1 sec? Thanks. Let's say 440 divided by 165 gives me I get 2.6667. How many digits should I go to? Look up here. How many digits should I go to? This is what? 2, 2, 2, 3, 3, 3. Final answer should be what? 2. Final answer should be 2 digits. So we're going to round this to 2.7. Look, if you want 2 digits, here's a little trick. If you want to round it to 2 digits, underline the first 2 digits. Then draw a little arrow on your next digit. Okay, some people look at like 2 or 3 digits beyond that. You don't do that. Underline the 2 digits you want to round it to, and then put a little arrow on the 3rd digit. Look at that 3rd digit. Is it 5 or bigger? Okay, then round the next one up to 7. So it works out to be 2.7 meters per second squared. If that one that I had the arrow on was a 4, then I would leave it as 2.6. If it's 5 or 6 or 7, I'd make it 2.7, round up. So what's different about this question? Not much, right? The fact that we have to find acceleration, but all we do there is add 1 extra step, include the mass. All right, let's take a look, please, at page 150. Now, this is a tricky question with the wording here, okay? So if you're having trouble with the wording, like what's what, let me know. Talk to me about that, okay? But try to work through it first yourself and see if you can figure out what it is. I'll give you a little hint, though. The trickiness comes to the mass, okay? Which mass to use, all right? If you're having trouble figuring that out, let me know, and I'll give you a hand with that.